So we want to talk a little bit about exponents, what they mean and how to use them. An exponent is a way to show powers of 10 or multiples of 10, or in student terms, an easier way to drop off a whole bunch of zeros. So if we take the number 10 to turn it into an exponent, because there's only one group of 10, we'd say 10 to the first power. In 100, there are two groups of 10, which is why 10 times 10 equals 100. To show that as an exponent, we say 10 to the second power. And an easy way to check to make sure you've got your exponents correct, in 10 to the second power, there are two zeros. Here there are two zeros. In our standard form, there are two zeros, which means for 1,000, it's 10 times 10, which is 100, times another 10, which gives us another zero and makes it 1,000. And you guys know when we say gives a zero, what we're really doing is adding an empty place value, changing how much this one is worth by moving it to a different place. Which means 1,000 is 10 to the third power. And a bigger number like 1 million, if we count our zeros or count our empty places, so it's 1, 2, 3, 4, 5, 6. A million is 10 to the sixth power. And this is a tool so that when scientists or mathematicians or somebody are using really big numbers, they can take the empty place values out, and they'll be less likely to make simple little mistakes based on place value, like putting things 10 times bigger or 10 times smaller. So the second part that we've learned that trips some people up is if you see something like 3 times 10 to the third power, which looks real fancy. But solving it is very, very simple. We have two pieces. 10 to the third power, which is 1,000, a 1 and 3 zeros, or 10 times 10 times 10, and 3. This we all know is 3,000. So if we try a bigger number, we need 72 with 5 empty place values represented as zeros. There's our 72. 5 empty place values represented as zeros. 1, 2, 3, 4, 5. 7,200,000. It's as simple as that.